Imagine waking up to a news alert. NASA confirms discovery of life on Europa. The world stops. Social media explodes. Governments, scientists, philosophers, everyone is asking the same question. What does this mean for humanity? For the first time in history, we're not alone. This isn't science fiction. It's a possibility rooted in science and technology. And the icy world of Europa may just be the place where it all begins. Welcome to Beyond Space, where we bring you the latest science news, deep dives into stellar phenomena, and visionary storytelling that pulls back the curtain on the cosmos unveiled. Today, we're exploring a question that has fascinated humanity for centuries. What if we actually found life on Europa? Europa, one of Jupiter's 95 moons, is one of the most compelling candidates for extraterrestrial life in our solar system. Underneath its thick shell of ice lies a global ocean, twice the volume of all Earth's oceans combined. This ocean is kept warm by tidal forces from Jupiter's immense gravity, creating a potential hotbed for life, despite the moon's extreme distance from the sun. Think about that. A dark, frozen moon possibly harboring alien microbes, or even complex organisms, right beneath our noses. In this episode, we're going to explore what life on Europa could look like, the science behind this fascinating possibility, the missions that aim to uncover its secrets, and what it would mean for the human race to confirm we're not alone in the universe. So buckle up, this is Beyond Space. So, why Europa? Out of all the moons and planets in the solar system, why has this icy world captured the attention of space agencies, researchers, and even science fiction writers? It all comes down to three ingredients scientists believe are crucial for life: liquid water, chemical building blocks, and energy. Europa checks all three. Liquid water. Its subsurface ocean is kept in a liquid state by tidal heating, the stretching and squeezing of the moon due to Jupiter's gravity. Chemical building blocks. Spectral analysis from telescopes and spacecraft shows evidence of salts and possibly organic compounds on its surface. Energy. Though sunlight is weak that far from the sun, Europa's internal heat and possible hydrothermal vents on its ocean floor could create environments similar to Earth's deep sea vents, known cradles of life. If Earth's hydrothermal vents can host entire ecosystems without sunlight, why couldn't Europa's? And there's more. The icy surface of Europa shows signs of recent movement and resurfacing, suggesting that material from below could be interacting with the surface, a phenomenon called cryovolcanism. This could mean that the ocean is not just liquid, but active and dynamic, cycling nutrients and heat in a way that could support life. Europa is also bombarded by radiation from Jupiter's magnetic field. While this radiation is deadly for surface life, it can split molecules like water and sulfur dioxide on the ice, creating reactive compounds that might then be transported down into the ocean. These oxidants could serve as food for life, completing the cycle. It's a chemical recipe that mirrors early Earth, and that's why scientists are so excited. Europa's ocean isn't just speculative. Multiple missions, from Voyager to Galileo to the Hubble Space Telescope, have confirmed strong evidence of water plumes erupting through cracks in the ice. These plumes suggest there's communication between the surface and the ocean below, meaning any potential life could be sampled without drilling miles through ice. In fact, some scientists believe that if we captured and analyzed one of these plumes, we might find signs of microbial life, like amino acids, fatty molecules, or even living cells. Europa's ocean could also contain salts like magnesium sulfate, similar to Earth's oceans, and with a possible rocky seafloor, interactions between water and rock could fuel chemical reactions that support life. This isn't just theoretical. On Earth, extremophiles, organisms that thrive in harsh conditions, live in the scalding waters of deep sea vents, beneath Antarctic ice, and even in radioactive waste. If life is that tenacious here, imagine what might exist on Europa. Let's break down how life might arise in such a world. Chemical energy. Hydrothermal vents, if they exist on Europa's seafloor, would spew out heat and minerals. On Earth, such vents support entire ecosystems without any sunlight. Chemosynthesis. Instead of using sunlight, organisms could use chemical reactions to produce energy. a process called chemosynthesis. Microbial ecosystems. Just like Earth's deep ocean vents, Europa's ocean might host microbial mats, colonies of bacteria feeding off chemicals like hydrogen sulfide or methane. Complexity over time. Life on Earth remained microbial for billions of years. It's possible Europa has done the same, or perhaps taken another path. Maybe complex multicellular organisms, adapted to pitch-black high-pressure environments, evolved over eons. Let's rewind. The story of Europa began in 1610 when Galileo Galilei first spotted it through his primitive telescope. For centuries, it was just one of Jupiter's moons, a bright dot in the sky. Then came NASA's Voyager missions in the late 1970s, which showed a smooth, icy surface, crisscrossed by brown-red streaks. Scientists were intrigued. What were these strange lines? Later, the Galileo spacecraft orbited Jupiter from 1995 to 2003, sending back crucial data. It detected magnetic field fluctuations that suggested a conductive, salty ocean beneath Europa's ice shell. Then came the Hubble Space Telescope. In 2012 and again in 2016, Hubble captured possible plumes erupting from the surface, raising the thrilling possibility that the subsurface ocean might be accessible. Each mission built on the last, turning Europa from a mysterious moon into a top candidate in the search for life beyond Earth. In addition to NASA, other space agencies like ESA and private space companies, even individuals like Elon Musk, have voiced interest in missions to icy moons. The journey to discover life on Europa isn't just theoretical, it's actively underway. 2 major missions are on the horizon, each with the potential to revolutionize our understanding of life beyond Earth. Slated for launch in October 2024 and arriving at Jupiter by 2030, the Europa Clipper is designed to perform dozens of close flybys of the Moon. Its goal? To determine if Europa's ocean could support life. Equipped with 9 advanced science instruments, the Clipper will map Europa's surface, analyze its ice shell, study its atmosphere, and, most crucially, fly through potential plumes. These fly-throughs may allow it to directly sample material ejected from the subsurface ocean. Among its suite of tools are radar for Europa assessment and sounding, ocean to near surface, reason, which can penetrate the ice shell and measure its thickness. Europa Imaging System, EIS, providing high-resolution images of the Moon's surface. Mapping Imaging Spectrometer for Europa, MISE, to identify compounds that could be biological in origin. Surface Dust Analyzer, SUDA, designed to capture particles in plumes and analyze their composition. If the Clipper detects organic molecules, amino acids, or even signs of microbial life, it will be a defining moment in space news and science and technology. The European Space Agency's Jupiter Icy Moons Explorer, JUICE, launched in April 2023 and will arrive in the Jovian system in 2031. While it will primarily focus on Ganymede, it will perform flybys of Europa as well. Together, JUICE and Europa Clipper represent a new era in planetary exploration, coordinated, multinational, and aimed squarely at answering one question: are we alone? But what if the answer is yes? What if these missions find life? Let's dive into that now. Imagine the moment when Europa Clipper sends back unmistakable evidence, microscopic organisms, or even just organic molecules that undeniably originate from beneath Europa's ice. The discovery would be seismic, shaking the very foundations of science, philosophy, and society. Here's why. First, scientific revolution. For centuries, humanity has wondered if life exists beyond Earth. Until now, all life has been confined to a single planet in the vast cosmos. Finding life on Europa would prove that life is not unique to Earth, that it can emerge independently elsewhere, even in extreme alien environments. It would redefine biology, forcing us to reconsider the very nature of life, its origins, and its resilience. Questions we've debated in the cosmos unveiled, about whether life is common or rare, would gain definitive answers. Second, philosophical and cultural impact. The discovery would ripple beyond labs and observatories. Religious, philosophical, and cultural paradigms would face new challenges and opportunities. Some might see it as evidence of a grander cosmic design, while others might interpret it as a random occurrence in the vastness of space. Humanity's self-perception would shift from being solitary caretakers of life to participants in a universe rich with possibilities. This moment would inspire art, literature, and storytelling in ways we can barely imagine. Third, technological leap and exploration drive. Confirming life on Europa would ignite an unprecedented push for exploration. Governments and private companies, from NASA and ESA to the visionary ambitions of Elon Musk and others, would accelerate missions to not just study, but eventually visit and perhaps even sample Europa's ocean directly. Technological advancements in robotics, AI, and space travel would surge forward to meet the challenges of exploring and protecting this newfound ecosystem. 4. The ethical frontier. Discovering extraterrestrial life would raise profound ethical questions. How do we protect alien life from contamination by humans? Should we interfere or simply observe? What are the responsibilities of a spacefaring civilization in preserving cosmic biodiversity? New laws and international agreements would be needed. Discussions already starting within the scientific community, but destined to expand dramatically. Europa is just one piece of the puzzle in the broader search for extraterrestrial life. Around the galaxy, astronomers are hunting for exoplanets, worlds orbiting other stars, in what is one of the most exciting frontiers of science and technology today. The discovery of thousands of exoplanets, many in the habitable zone where liquid water could exist, has opened new horizons. Missions like TESS and the James Webb Space Telescope are revealing atmospheres that may harbor signs of life, methane, oxygen, or other biosignatures. But Europa and other icy moons, like Saturn's Enceladus, offer closer-to-home laboratories where life might exist under thick ice shells, protected from harsh space environments. Our solar system's ocean worlds could be the first places we confirm life beyond Earth, a breakthrough that would energize and inform the search for life on exoplanets. The exploration of Europa and beyond isn't just the domain of governments. Elon Musk and SpaceX have revolutionized space access, reducing launch costs and inspiring a new generation of explorers. Visionaries like Musk have expressed ambitions to colonize Mars, but the technologies developed, reusable rockets, advanced robotics, AI, could also be critical to exploring icy moons. Private companies could partner with space agencies to develop probes, landers, and even underwater drones designed to penetrate Europa's ice. The future of space exploration will be a collaboration between public and private sectors, driven by shared curiosity and innovation. As we watch missions like Europa Clipper and JUICE unfold, it's vital to keep the public engaged. Platforms like Beyond Space serve a critical role in bringing space news and cosmos insights to a broad audience. Public enthusiasm fuels funding, political support, and scientific breakthroughs. By sharing the story of Europa and the quest for life, we not only educate, but inspire the next generation of scientists, engineers, and dreamers. What would finding life on Europa mean to you personally? How do you think it would change humanity's place in the cosmos? Share your thoughts in the comments below. Don't forget to like this video and subscribe to Beyond Space for more journeys into stellar phenomena, space advancements, and the cosmos unveiled. Finding life on Europa would mark one of the greatest discoveries in human history, a testament to our unyielding quest to understand the universe and our place within it. As we stand on the brink of this incredible journey, remember, every step beyond space brings us closer to answering the age-old question: are we alone? Until next time, keep looking up, stay curious, and join us here at Beyond Space, where the universe's greatest mysteries await.